March 12, 1944, 3:47 a.m. American sonar operator Lieutenant Robert Hayes stared in disbelief at his screen. The German U-boat U-264, the one they'd been hunting for the past 18 hours, had vanished, not destroyed, not surfaced, simply gone. Hayes reported what seemed impossible to his captain. The German U-boat had been continuously submerged for 37 hours. Every Allied submarine had to surface after 48 hours to recharge its batteries. The Germans had doubled that. The captain grabbed the encrypted radio and reported to Naval Command. "The Germans have changed the rules of submarine warfare. We don't understand how." In the spring of 1943, the German Navy faced a deadly problem. Allied aircraft and destroyers had learned to locate and destroy U-boats when they surfaced. Every U-boat had to regularly come to the surface to run its diesel engines and recharge its batteries. These moments were lethal. In March 1943 alone, Germany lost 41 U-boats in a single month. Most were caught while surfacing. Admiral Karl Dönitz, commander of the U-boat forces, knew that if German U-boats continued to surface, they would all die. The solution came not from the German Navy, but from a Dutch engineer named J.J. Witches, whose 1940 concept was perfected by the German Navy in 1943, the Snorkel. The principle was astoundingly simple, but the technical implementation was ingenious. A retractable pipe mast that extended above the surface of the water while the U-boat remained at periscope depth. Fresh air flowed through this pipe to the diesel engines, while exhaust gases were expelled through a second pipe. The U-boat could recharge its batteries without fully surfacing. The technical challenge lay in the details. In rough seas, water would slam into the intake pipe and could flood the diesel engines. German engineers solved this with an automatic float valve. When a wave flooded the pipe, the valve closed instantly. The diesel engines then sucked air from inside the U-boat, creating a painful underpressure. The crew had to endure earaches and shortness of breath, but the boat was safe. This simple solution enabled German U-boats to remain submerged for weeks. The first snorkels were installed on Type 7 U-boats in the summer of 1943. U-264, under Commander Hartwig Lux, received its snorkel in January 1944 and became the test case. The first patrol lasted 62 days, of which the boat spent 58 days submerged. Only for torpedo attacks did it rise to periscope depth. Allied forces were baffled. Their radar and sonar equipment were designed to detect fully surfaced U-boats. A narrow pipe that barely protruded above the surface of the water was virtually invisible. The radar signature was minimal. Sonar couldn't pick it up. Visually, it was only visible in calm seas and at close range. The Germans had effectively created invisible U-boats. The first documented Allied report about the Snorkel came on March 15, 1944, written by Commander James Harrington of the Royal Navy. After the futile hunt for U-264, he wrote, "We pursued the enemy U-boat for over 200 nautical miles. Our sonar showed continuous contact, but the boat never surfaced. Our aircraft circled for hours. Nothing. No radar echoes. No visual sighting. Then we lost contact completely. Either the Germans have developed a new technology that allows them to stay underwater indefinitely, or they have found a way to breathe without surfacing. Both seem impossible, but it is happening." Harrington's report was classified as top secret and landed on the desk of Admiral Max Horton, commander of the Western Approaches Command. His marginal note was simple: "Find out how they do it. Our submarines need this too." The technical sophistication of the German Snorkel was evident in the details. The intake pipe had a diameter of 8 inches and was 30 feet long. It extended hydraulically from the U-boat's conning tower. At the top, sat the automatic float valve, a construction of metal and rubber that closed in milliseconds when hit by a wave. The exhaust pipe for the exhaust gases was 6 inches thick and ran parallel. German engineers had coated both pipes with a special rubber coating that absorbed radar waves. This early form of stealth technology reduced the radar signature by about 60%. In choppy seas, the Snorkel was virtually invisible to Allied radar. The impact on submarine warfare was dramatic. Before the Snorkel, a Type 7 U-boat had to surface every 36 to 48 hours for at least 4 hours to recharge batteries. With the Snorkel, it could remain submerged for 40 to 60 days at a time, only briefly at periscope depth to snorkel. The loss rate of German U-boats dropped immediately. In April 1943, before the Snorkel, the Germans lost 56 U-boats. In April 1944, with snorkel-equipped boats, the number dropped to 22 U-boats. The survival rate nearly doubled. Allied commanders were desperate. Their entire anti-submarine strategy was based on catching U-boats when they surfaced. The Germans weren't surfacing anymore. When the first captured Snorkels were analyzed in the summer of 1944, the technical superiority of German engineering was revealed. An American report from July 12, 1944, written by Captain William Thompson of the Bureau of Ships, describes the examination of the Snorkel from U-250, which was captured by Soviet forces. The design is simple, but brilliant. The automatic valve uses a floating metal body that is pushed upwards by buoyancy upon contact with water, pressing a rubber seal against the pipe. The entire mechanism has only 7 moving parts. We have tried to replicate this design, but our valves fail after 20 to 30 closing cycles. The German version works for over 1,000 cycles without failure. The material quality, especially the rubber, is superior to anything we can produce. Thompson recommended copying German Snorkels directly, including the use of German materials and manufacturing methods. The British Admiralty ordered the immediate development of its own Snorkel. The project was launched in August 1944 under the codename Indiscretion. British engineers had access to captured German Snorkels and complete technical drawings. Nevertheless, the first attempts failed spectacularly. A British engineer, Commander Peter Scott, wrote in his report from October 3, 1944, "We understand the principle perfectly." The realization, it was overwhelming. Our first valve failed on its very first deployment, flooding the engine room of HMS Tribune. 2 men drowned. Our second attempt lasted a mere 4 hours before the pipe fractured in a force sea. Our third attempt worked, but the radar signature was 3 times higher than the original German design. We can see German technology, touch it, measure it, but we simply can't build it. It's humiliating. The Allies' desperation was showing in drastic measures. In the fall of 1944, the US Navy ordered the creation of a specialized task force dedicated solely to Snorkel development. Over 50 engineers were pulled from other projects. Their singular mission, build a working Snorkel. The project devoured $2.3 million, an enormous sum, in 1944. The first functional American version wasn't completed until March 1945, almost 2 years after the German introduction. But even this version was inferior to the German original. A comparative test in April 1945 revealed the German Snorkel had a failure rate of 0.3% after 500 hours of operation. The American Snorkel, 8.7%. German engineering was unrivaled. The Snorkel's technical superiority wasn't just about the valve, but the entire system. German engineers had perfectly integrated the Snorkel into the U-boat architecture. The diesel engines were modified to work with the fluctuating air pressure caused by the automatic valve. Special pressure equalization valves protected the crew from dangerous negative pressure. The exhaust pipe had an integrated water separator which prevented seawater from flowing back into the boat with the exhaust gases. Every detail was thought through. The Americans copied the components, but they didn't understand the system. The result were snorkels that functioned but weren't reliable. The Snorkel also fundamentally changed U-boat tactics. German U-boat commanders developed new attack strategies. They could now operate in coastal waters, where Allied submarines were easy targets due to frequent surfacing. They could stalk convoy routes for days without being detected. The Snorkel U-boats became ghost hunters. A British convoy commander, Captain Michael Stevens, described an attack on January 18, 1945. "We knew a U-boat was near. Our sonar had a weak contact, but we never saw it. No periscope wake, no radar echo, nothing. Then at 23:17 hours, 3 torpedoes out of nowhere. 2 hits, SS Normannia and SS Belfast to sinking. The U-boat vanished again. 37 men died. We had no chance to strike back. How do you fight? An enemy you can't see?" The production of snorkels became a priority for the German Navy. By the war's end, over 400 German U-boats were equipped with snorkels. The manufacturing was astonishingly efficient. A complete snorkel unit cost approximately 8,000 Reichsmarks to produce and could be manufactured in just 6 days. The Germans had produced up to 60 snorkels per month in various shipyards. In comparison, the first American snorkel production line, opened in June 1945, managed just 4 units per month. German mass production was another miracle of engineering. After the war ended, the snorkel became the most sought-after piece of German U-boat technology. Operation Deadlight, the Allied effort to scuttle German U-boats, had a secret exception: U-boats equipped with snorkels. These were not sunk, but divided among the Allies. The United States received 10 snorkel U-boats, the Soviet Union 12, Great Britain 15. Each nation studied the technology intensively. An American intelligence report from June 15, 1945, summarized the situation. The German snorkel is the most important U-boat innovation since the torpedo. Every modern navy needs this technology. We cannot develop it ourselves in an acceptable time frame. We must copy German designs and recruit German engineers. Operation Paperclip, the program to recruit German scientists, dedicated considerable resources to snorkel technology. Of the 1,600 German experts brought to the United States, at least 47 worked on U-boat projects. Many had worked directly on snorkel development. A now declassified report from the Joint Intelligence Objectives Agency from 1946 lists Dr. Carl Luth as target number 8, one of the most important targets. Luth had developed the valve technology for the snorkel. He worked from 1946 to 1958 for the Naval Research Laboratory in Washington. His primary task, developing improved snorkels for American submarines. Without German knowledge, America would not have had reliable snorkel technology. The Soviet acquisition of snorkel technology was more direct and ruthless. As the Red Army captured German U-boat shipyards, they seized not only U-boats, but entire production facilities. Over 200 German U-boat engineers were deported to the Soviet Union. A Soviet report from 1946, only declassified in 1992, describes the operation. German specialists were brought to Sevastopol and instructed to organize the production of snorkels. They worked under guard, but with complete technical freedom. Within 10 months, They produced the first Soviet snorkels. These German engineers, whose names largely remained unknown, laid the foundation for the Soviet submarine fleet of the Cold War. The importance of the snorkel during the Cold War was immense. Soviet Whiskey-class diesel submarines, introduced in 1951, used snorkel systems, directly copied from German designs. A CIA report from 1953, only declassified in 2008, analyzed a captured Soviet snorkel. The valve system is an exact copy of the German original from 1943. Even the production stamps showed German tools. The Soviets have not attempted to improve. They have perfectly copied. This demonstrates their dependence on German technology. The irony: Soviet submarines hunting American carrier groups in the North Atlantic and were using technology that German engineers had developed to hunt Allied convoys. The French Navy took a different approach. Instead of copying directly, they recruited German engineers as consultants. Between 1946 and 1952, at least 15 German snorkel experts worked for the French. Direction de Construction Naval. Their mission: develop advanced snorkels. For French submarines, a French naval report from 1949 is remarkably honest. Without German expertise, we wouldn't have a modern submarine fleet. Our own attempts failed consistently. The Germans understand an engineering level that we can't reach. It's no shame to admit it, but a strategic reality to accept. France's first successful post-war submarines, the Naval class, used snorkels that were 80% based on German design. The influence of the German snorkel on modern submarines is absolute. Every conventional submarine in the world uses a snorkel. The American Los Angeles class, although nuclear-powered, has a snorkel for emergency situations. The German Type 212, the most advanced conventional submarine in the world, uses a snorkel directly descended from the 1943 design. The basic principles haven't changed. Extendable tube, automatic valve, diesel operation at periscope depth. German engineers perfected this technology 80 years ago, and no one has found anything better. The technical documentation of the snorkel, now in archives worldwide, reveals the German engineers' obsession with detail. Technical drawings from 1943, kept in the German Federal Military Archives in Freiburg, show tolerances in the range of hundredths of millimeters for the float valve. The rubber seals had to function at temperatures from 4 to 104 degrees Fahrenheit. The hydraulics for extending the tube had to work under water pressure down to 200 feet. Every detail was specified. This precision enabled mass production without loss of quality. The irony of the snorkel story lies in its origin. The basic idea came from a Dutch engineer, J.J. Wichers, who filed a patent in 1940. The Dutch Navy showed no interest. When Germany occupied the Netherlands, German engineers confiscated the patent. They immediately recognized the potential. Within 3 years, they transformed a theoretical concept into a functioning weapon that revolutionized submarine warfare. This ability to recognize potential and quickly implement it was typical of German engineering in World War II. The snorkel also enabled the development of the Type 21 U-boats, the first true electric submarines. These revolutionary submarines were designed for longer underwater voyages, but they still needed regular battery charging. The snorkel made this possible without surfacing. A Type 22 could theoretically remain submerged indefinitely, only surfacing occasionally to snorkel at periscope depth. Allied naval experts recognized after the war, if Germany had had 2 more years, these snorkel-equipped electric boats would have been uncontrollable. The combination of snorkel and Type 21 could have tipped the Battle of the Atlantic. The experiences of German U-boat crews with the Snorkel show both sides of the innovation. Petty Officer Heinrich Weber, a machinist on U-482, described the reality of snorkeling in a 1987 interview. "The automatic valve saved our lives, but it also tortured us. When a large wave hit the tube in a storm, the valve closed. The diesel engines then sucked air from the boat. The negative pressure was so strong that your ears hurt, as if needles were being stuck into them. Some men got nosebleeds. We all had chronic headaches, but no one complained. We knew every minute underwater was a minute we lived. Surfacing meant death." Weber survived 6 patrols on U-482, a U-boat that remained submerged for 47 consecutive days. The psychological effects of snorkeling on the crew were significant. Without sunlight, without fresh air except through the narrow snorkel, without the possibility of going on deck, many crew members developed what German doctors called snorkel sickness: headaches, dizziness, depression, loss of orientation. A German Navy doctor, Dr. Hermann Schultz, documented the medical consequences in a report from August 1944. Of 120 crew members on Snorkel U-boats, 87 showed symptoms of chronic oxygen deficiency. 34 suffered from severe psychological stress. But the survival rate of these boats was 3 times higher than that of conventional U-boats. The men suffered, but they lived. That was the trade. The technical development of the Snorkel went through several iterations. The first generation, introduced in the summer of 1943, was simple but functional. The second generation, from December 1943, added improved radar-absorbing coatings. The third generation, from April 1944, integrated a head fan that circulated air in the boat and mitigated the pressure fluctuations. The fourth and final generation, from October 1944, had a double-walled snorkel with cooling water between the walls, which reduced the infrared signature. Each version was developed and implemented in just a few months. The speed of German innovation was remarkable. Allied attempts to combat Snorkel U-boats led to desperate tactical changes. The RAF developed special low-flying patrols that tried to visually detect the narrow snorkel tubes. The success rate was minimal. Of 847 low-flying missions between January and May 1945, pilots sighted only 12 snorkels, and only 2 of these led to successful attacks. An RAF pilot, Flight Lieutenant Charles Bradford, described the frustrations. "We flew 50 feet above the waves. For hours, our eyes ached from staring at the sea. A snorkel was a black pipe, as thick as a broom handle, in millions of square miles of ocean. The chances of seeing it were astronomically low, and even if you saw it, the U-boat was gone in 20 seconds, submerged to 300 feet. We were fighting ghosts." Post-war development of snorkel technology has led to gradual improvements, but no revolution. Modern snorkels use better materials, electronic controls instead of mechanical valves, radar-absorbing coatings, but the core principle is identical to 1943. A tube with an automatic valve. An American naval engineer who worked for Electric Boat in 2003, which builds submarines for the US Navy, confessed in an interview, "We've refined the design, but haven't fundamentally changed it. The Germans solved the problem with the simplest, effective solution. 60 years of research haven't found a better approach." That's frustrating and impressive at the same time. Snorkel technology has even found civilian applications. Modern emergency generators in basements use similar automatic valves to safely vent exhaust gases. Industrial combustion plants. They actually utilize the principle of pressure equalization, a concept that German engineers originally developed for the Snorkel. Mining companies. They use snorkel-like systems for ventilation in deep shafts. The technology, born from military necessity, now serves civilian purposes. And here's a remarkable detail that shows the enduring relevance of German Snorkel innovation. The Israeli Navy. They sourced their Dolphin-class submarines from Germany. And they specifically requested snorkels based on classic German designs. An Israeli naval officer, whose name remains classified for security reasons, stated in 2015, quote, "We tested American or French and German snorkel systems. The German ones were superior in reliability, stealth, and ease of maintenance. Not because Germany invested more, but because they have 70 years of experience with a design that was right from the start. The fundamental principles from 1943, they're still the best solutions today. Now, the recognition of the snorkel as a groundbreaking invention. It only came decades after the war. During the war, Allied propaganda offices, they tried to downplay its significance. Reports about invisible German U-boats, they were censored. It wasn't until the 1960s, when classified documents were declassified, that an honest analysis began. A British naval historian, Commander John Moore, he wrote in his 1968 book, Submarine Warfare 1939-1945, quote, "The snorkel was the most successful defensive innovation of the German Navy. It not only extended the lifespan of German U-boats, but it forced the Allies to completely rethink their anti-submarine strategy. German engineering, out of desperation, it created a technology that's still standard today." These technologies, they're not just history. They're in every modern submarine, every naval operation, every underwater system, from the American Virginia-class submarine to the Russian Kilo-class to the German Type 212. They all use snorkels based on the German design from 1943. If you appreciate these technical truths, support this channel with YouTube's Super Thanks. Every Super Thanks allows me to dig deeper into archives, digitize rare submarine blueprints, and interview surviving engineer witnesses. Help me preserve this technical history before it's forgotten. The story of the snorkel. It's ultimately the story of a technical solution, born from existential threat. German U-boats. They were dying when they surfaced. German engineers. They created a way to not surface. This simple problem-solving approach, it revolutionized submarine warfare forever. Before the snorkel, U-boats were submersible ships that went underwater periodically. After the snorkel, they became true submarines, rarely touching the surface. This fundamental change, it still shapes how nations conduct underwater warfare. Recently released documents from the British National Archives, they show that Winston Churchill, he was personally briefed on the snorkel, a memo dated April 22nd, 1944, to the War Cabinet. It's remarkably direct. Quote, "The Germans have developed a technology that's making our submarine defenses obsolete. Their U-boats can stay submerged for weeks. We must acquire this technology, no matter what." Churchill's handwritten note was simple: priority absolute. This honesty about technical inferiority, it was rare in Allied leadership, but it led to concrete action, intense efforts to capture and copy German snorkels. The connection between the snorkel and modern technology, it's not just technical, it's conceptual. The snorkel demonstrated a principle that's applied in many areas today. Stealth through signature reduction. The Germans reduced the radar signature through special coatings. They eliminated the visual signature through periscope depth operation. They minimized the acoustic signature through slow snorkel speed. This multi-spectrum stealth philosophy, it's standard in military technology today, from stealth aircraft to modern warships. The personal accounts of Allied sailors who fought against snorkel-equipped U-boats, they show frustration and respect. Commander David Jones, who escorted 4 convoys in 1944-45, He wrote in his memoirs in 1982, quote, "We knew there were U-boats out there. Our intelligence reports were clear, but we never saw them. No radar echo, no periscope sighting, only occasionally a torpedo wake, out of nowhere. Men died, ships sank, and we couldn't do anything. That wasn't an honorable fight. That was hunting, and we were the prey." Jones lost 3 ships from his convoys to Snorkel U-boats. None of the attacking U-boats were sunk. The technical superiority of the Snorkel, it was so obvious that even during the war, there were attempts to steal German examples. A declassified OSS report from September 1944. It describes a failed operation where American agents tried to smuggle Snorkel components from neutral ports where German U-boats had docked. The operation failed, but it shows the desperation of Allied intelligence to gain access to German technology. After the war, hundreds of captured Snorkels, they were sent to Allied research labs, studied, disassembled, measured, a silent tribute to their technical excellence. What German technology has surprised you the most? Many naval engineers in the comments, they've pointed out incredible connections. Grandfathers who worked on U-boats. Technical drawings in shipyard archives, modern patents with German roots. Share your technical discoveries. Every comment is a puzzle piece of engineering history. The Snorkel stands as a symbol of German engineering under extreme conditions. In a time when Germany was losing the Atlantic, U-boats were dying in droves. Resources were dwindling. German engineers, they created a technology that revolutionized submarine warfare. A technology so fundamentally right that 80 years later, every submarine in the world uses it. The American Virginia-class submarines, the Chinese Yuan-class diesel boats, the German Type 212s, they all carry Snorkels, whose basic design was perfected in German shipyards in 1943. Technology knows no borders, no nationalities, no politics. It knows only one rule: what works, survives. The Snorkel worked, and it survives. In every modern submarine,